This is part 2 of our International Observe the Moon Night. So it takes place on September 22nd, regardless of where you are on Earth. We're following the time along from the international dateline across the globe. Joined with us is we have Ahmet Kale, who's in Turkey. He's actually eating dinner right now, but he did leave his image of the moon up for us. I am Scott Lewis. I am the bald astronomer on Twitter and work with CosmoQuest in their education and public outreach. And we have Nicole Gallucci, who is on location at the Franklin Institute in Philadelphia, Pennsylvania. The noisy astronomer, or the postdoc with the most rock.
Yeah.
And so I don't slaughter your guys' name. Could you introduce yourselves from Denmark?
My name is Jens. I'm a student of astronomy, I guess we can call it, and Christian, my colleague, also a student, and we're both working at the observatory here.
Fantastic. And what are you guys majoring in with your astronomy? Planetary? Are you doing more stellar, galactic?
Well, Christian is doing cosmology, and I am a bit undecided.
Okay. There's a lot to choose from.
It is. You know, you got a universe.
Yes. You have all the universe to choose from, and it's hard to narrow that down sometimes. So for everyone that doesn't know, the International Observe the Moon Night is when we do take the time to look up, regardless of where we're at, and get a perspective of no matter where we are in the world, no matter what part of this rock that we were born in, we all share the same neighbor. We all share the moon. And we all have our own experiences growing up and the lore that we might have been told, whether true or false. And it's a great way of connecting together as a species of humans to appreciate that we all share something in common. We're all able to share in this adventure of looking up and being mesmerized by this beautiful object that we have hanging over in the sky. We've been having events all night, or all day. We started off in Australia and New Zealand, where we had Paul Stewart share his view from New Zealand, while Dr. Pamela Gay and I discussed for a few hours the awesome times. We'll also be going into CosmoQuest and what you can do to participate in exploring the moon on your own, that we all have a way of doing actual scientific research about the moon using the tools such as the Lunar Reconnaissance Orbiter camera. And we also just love doing education and public outreach, talking with you. So if any of you have questions or comments or any stories about the moon, please feel free to leave comments on our Google Plus with CosmoQuest. Also on Twitter, if you use the hashtag MoonNight, we will be able to check those comments as well as our event page that we have on Google Plus. Now, in Denmark, we are looking at the moon through a tree because it's quite low in the sky. You guys said it was around 20 degrees above the horizon, is that correct?
Something like that, yeah.
So for everyone knows about the 20 degrees I'm talking about, straight up the zenith is 90 degrees and the horizon 0. So we're going up in increments of 10. It's not that high up in the sky. I know here in the States we'll be dealing with about 30 degrees above the horizon. So it's fairly low at this time of night, or actually this time of the month. Nicole, what are you doing over at the Franklin Institute?
So what I'd like to do, since I'm limited on data and on battery, I'd like to take you around and see some of the demos that they're doing here at the Franklin Institute for Observe the Moon Night. Let's find a table that's not too crowded first. On location means everything's going to be a little bit crazy.
Yes.
But first, we're going to stop by the Penny Orbit, and we'll have you listen in on one of the demonstrations.
Oh, that's cool. Have you watch this?
I don't know if you can see what's going on, but the volunteer has a clear balloon, and inside is a penny.
I gotta go back to the balloons.
They're giving out some. Would you like to show this? I'm broadcasting. Would you like to show this on the internet? Okay, here you go. So we have. Hi. Let me see. So they get a coin, a penny, going in the inside the balloon, and it's simulating the moon's orbit around the Earth. And now, why don't you twirl around while you're doing that? Can you twirl around? Woo! Spin yourself around. Yeah. So the point of this demonstration is showing how the moon orbits the Earth inside there while the Earth is orbiting the sun. Good job, thank you. Did that come through okay?
That came through great, Nicole. And that is a great way of visualizing and what exactly is going
So
on.
they have a all you need are these clear type a penny. A marble works really well as well. Yeah, do whatever you want.
Alright, so, I mean, it would help if you, alright.
Can you guys hear him?
Your dad is kind of cutting out.
Scott?
Your dad is cutting out.
We may be
but
frozen.
You're coming through.
Hey, Scott.
Go ahead. You're good.
You're coming through. Can you hear?
Yes, you're good.
Over here? Okay, so why
alright.
don't you come on this side and speak into it?
Alright. Oh, alright, so basically, I think they're saying that.
Yes,
Yeah,
yes.
there, okay, alright, so all we're doing is we're just trying to match the pictures of the face of the moon with the names, right? So what we would do is say, so the first one we say is new moon, right? So
Yes.
basically we put the,
So it's showing us the new moon.
what's going to happen the next day, it's going to get a little lighter. The one in the middle will be a little lighter. That was this one, right?
Yep. So now we got one
down
crescent.
there. And then the next day will be, here you want to up and up?
Now he's got another visitor. So what they have them doing is they have these different moon pictures, and then you're basically putting it where labels are for the moon phases, teaching moon phases.
Very good.
And after that, they have some balls, and they have a really bright light overhead, I'm going to blind you, that is using as their model sun and getting people to actually put the ball around them in a way that gives them an idea of how the moon phases work using shadow.
Yeah. Which is essentially what's going on, is we're looking at it from the same light source, but from different angles.
Right. You see, she's moving along. Filling in the moon phases.
Oh, and gravity still works, even on the moon.
Gravity still works. It's very important. All right, and I'm going to take you over to another table where, so my boyfriend Tim is helping out. We already visited the Moon, Sun, Earth model table. So there's a paper model that you can make that shows how the moon, it's not to scale at all, but it's really cool that it shows how the moon goes around the Earth, and then the Earth goes around the sun using this paper model and little pins and clips that keep it together. So.
Great job, Tim.
There we go. Good job.
Tim gets a thumbs up.
Thumbs up. So they've got visitors cutting out the sun. I think is the most labor-intensive part of this project.
Absolutely.
And
There's so many
run down.
triangles.
And I would like to show you the crater demo, but it's currently full of people. So you'll have to come back another time for that, I guess. We have there's a full demonstration where you put flour and cocoa powder or sand in a container, and then drop marbles and balls into it to simulate how craters would form on the surface of the moon. But that seems to be very popular right now, and it's surrounded with kids.
And didn't we have a hangout regarding that the other 2 days ago with you and Pamela in Georgia?
Yeah,
So-
on Wednesday night we did a science hour talking about Terra Luna, which is the teacher program that we're putting together using CosmoQuest and teaching the moon and actually tying it to the next generation science standards. and that is part of the activity. So the instructions for that should be posted soon if they're not already. You can also go to Google Dark Skies Bright Kids. It's a group in Virginia I used to work with that they also have a lesson plan on how to do that activity.
Awesome. So yes, for all you watching here on Google Plus, that is on our Google Plus page. Just go to the history. You will see the Science Hour, and you can actually watch all of that. All the links are either there, or we can link you all to them from our site.
Yep. So I am really excited to see all these people here for these moon events. It's as soon as you walk in on the way to the artificial heart. Let me show you the view again. This is the hallway on the way to the artificial heart. They have all these great moon demos set up. They have a whole bunch of volunteers working. So this is, science guerrilla outreach out to the public. Later today, Tim and I are going to see a talk on myths about the moon. So that should be pretty fun.
Well, and if you have to go, because I understand that it's loud and you have a lot of things going on, make sure to take pictures and put them up into our event page so we can share with everybody else what's going on.
Great idea. Great idea. All right, I will sign off, and you can have a peaceful watching hangout.
Well, the noisy astronomer, everyone. It's got to be noisy, right?
Exactly.
All right. Thanks,
but
Nicole.
I'll be back tonight from a quieter location for our West.
Yes, that will be wonderful. That will be in around 6.5 hours is when we start with that. So.
Okay. Yeah, we may be clouded out here, so I'm counting on you guys and your telescopes to show me the moon.
All right. All right. Thanks, Nicole.
All right. Thanks, God. Thanks, everybody. Thank you, Tim.
Thank you, Tim. Now, before we lose our view, we are actually now able to see the moon through the trees because the moon is so low in the sky. But you just have an amazing view of just peeking through between those leaves.
Indeed. Well, at the moment, yeah, but we might have some tree issues again in a few minutes. We're actually trying to mount a normal webcam on our second telescope.
Oh, fantastic.
To see if that one might get a better view.
Now, what type of telescopes are you guys using over there in your observatory?
You should be able to see in a few seconds.
Okay.
I hope.
And while you guys are transitioning, I want to introduce our other astronomer in Turkey, Ahmet Kale. He's back from dinner.
Yeah. Hello, everyone.
And what time is it out there in Turkey?
It's 8:40 p.m. now.
8:40 p.m.
Yes.
So you are 10 hours ahead of us here in the Pacific, or 5 hours Eastern.
Yes, right.
And I believe in Denmark it is now 7:40 in the p.m. If I'm doing my math correctly, which is very possible I'm not in my head. So, real quick, Akba, what are your telescopes you're using right now?
I have a Celestron C9.25. It's a Schmidt-Cassegrain telescope. I have a Flea 3 camera right now.
Very nice.
And it's f10 now.
So you're at f10 with your focal?
Yeah. Yeah, it's the prime focus now. I didn't add Bardon, but because seeing is not good now.
Well, even still, I do like how we are able to see the atmosphere. So if everyone's looking at the moon, we're seeing just these waves going on. That's actually the air or atmosphere that's waving. So the light's actually going around, coming from the moon through the atmosphere and coming to his camera. So we're actually able to see the air coming or between us and the moon, which is really interesting. It almost looks like looking through water because this is a gas and it has fluid dynamics. So we're actually able to see the waves going on with it. And it looks like we have Christian again has his moon back up. And again, it's great having to see both a close-up and a more zoomed out look. So we're able to see the larger seas of the moon, where we had some lava flows a long, long time ago. The volcanism is no longer active, but we're able to see some of the craters. But if we move back over to Akhmet, we're able to see some great detail going on, where you're able to see impacts within impacts in the shadow. So you're able to see where the sun is and coming from. So the shadow and the ridges are lit up as well. So it really gives you a feel that it is a three-dimensional object. I know myself growing up, it was really interesting. It was just a small circle in the sky, and the first time I was able to look through a telescope, I was able to see these features that made it turn into a sphere, not just a smooth sphere, but it has valleys and it has all these pockmarks on it from these violent crashes that happen on it all the time. And yes, we can see here that we are having a tree problem, but it's something that, you know, it happens. With astronomers, we deal with a lot of not less than ideal conditions, but it's about getting out, and we're sharing this with everyone. I'm glad that we're able to hook. We're hooking up 3 different countries right now, sharing it with the world. So, you know, I'm here in the United States, Ahmed's in Turkey, and Christian is over in Denmark. So we wouldn't typically be able to come physically hang out with one another, but we're all able to share the moon by just looking up. And now with technology, we do have the internet for that. And it looks like we lost Christian. He should be back here momentarily, I believe. But while we do so, just letting you all know, there are local events all over the world for International Observe the Moon Night. And so what you can do is you head on over to observethemoonnight.org. As you can see here on the map, you're able to find places all across the globe where people of all ages, race, religions, no matter what, no matter where they're born, what they believe, we're all getting together to share in observing this moon. And so right now we have Ahmet here in Turkey, and when the guys come back again, they're up here in Denmark. So we're literally connecting the globe, and to be able to share the wonder that we have many differences in the world, but we also have many similarities. We have many opportunities to share and do remarkable things together with one another. So feel free to go to observethemoonnight.org. You're able to find different events all over the place, and they have them set up as either tweet-ups. We are using the hashtag MoonNight, and we're able to share on that. And many things are going on, just like Nicole's having in Philadelphia, where there's many teachable moments and ways of getting to understand the moon where we might not have correctly understood. I know that growing up I was told some incorrect things about the moon, and the only way we're able to find out what's real is by actually going out and being curious and asking those questions and finding the correct answers. Now, Ahmed, I was wondering, growing up, did you ever have any mythology or any lore about the moon? I know, like the man in the moon, or the rabbit, or here in the United States, there's a funny little myth that the moon is made of cheese. Is there any stories like that you heard growing up?
Yeah, I haven't heard, but I I just interested in astronomy about a few years.
Mm-hmm.
Maybe there is, but I don't know.
Okay. And so, do you remember the first time you looked at the moon through a telescope?
I look at the moon with my first telescope about 2 years ago.
Oh, 2 years ago. Okay.
Yeah.
So quite recent.
Yeah, quite recent. But first time when I saw the moon through the telescope, it's amazing, you know.
Isn't it?
Yeah. Yeah, I shocked seeing the details and the craters. It's just amazing. And
Absolutely.
everyone who see the moon through the telescope for the first time, they are react like that. Just wow.
Yeah, absolutely. I mean, I know that we're used to seeing it as just a small circle or part of the circle, and being able actually to see the terrain, you know, it's really, it blows your mind thinking that this is our closest, you know, heavenly body that's out there. It's our closest planetary body, and we come accustomed. We don't even notice it half the time when it's up in the sky. Yet we're able to learn so much about it just by using some glass and bending it at the right way. We're able to see it and in great detail.
Yeah.
And we've been able to not only be curious about that for thousands of years, but we've been pushed to now. We've been on the moon. We've had human beings on this object that we so often forget about by just, you know, by not paying attention. But we've had people on it. There have been multiple people walking around driving a car on the moon. Their rover that they had on there. So we've had people. We've been able to bring back rocks from the moon, which is insane. We think about going for a trip. The furthest I've driven is 2,000 miles, and to think about having to go over 300,000 kilometers and then turning around and coming back with some rocks.
That's amazing.
Isn't it?
Yeah.
So I wanted to make sure everyone knew that there are different resources that are available for us to understand the moon better, that you don't necessarily have to take an astronomy course to get a better understanding of the moon. One of them is actually made by Universe Today. So Fraser Kane, who is the co-host with Dr. Pamela Gay of CosmoQuest, has created an app for both Android and iOS. It's called Phases of the Moon, and the author on there is Universe Today. And what it has here is, if I can get the glare away, is we're able to see the moon, and you're able to go through and see it through its different phases on its day. So we have the date going on up here, we have the phases going through, and also will give you what the phase is. So right now it's showing at a waxing gibbous, but it also gives you the amount illuminated, the approximate, you know, distance away. So on September 26th, for instance, it's 383,000 kilometers away. And it gives you it when it's rising, when it's setting. So you're able to go forward and backwards in time with this. And it's only 99 cents. It's great. It's something that you can always have with you. And what I love about it as well is that there is a term called libration that the moon does, and that actually the Earth does, and many bodies do. So as we can see with the glare stop being pain, that the moon kind of wobbles. Move that here. So the moon kind of wobbles along, and so we actually see over the course of a month, we see 59% of the lunar surface. We see 50% at each time, but since the moon orbits around 29.5 days around the Earth, we actually get to see it shift and move around. So we get to see 59% of it, which is great. So we always think of we never get to see the far side of the moon, but we actually do get to see quite a large portion of the moon that we don't typically get to think about. And if you went out and took a picture every night of the moon, you'd be able to actually see this motion happen, and it's happening all the time. Have you, Ahmed, have you stacked any images of the moon night after night after night?
Actually, I can only image on the weekend.
Okay.
So just every weekend maybe.
Every weekend?
Yeah.
So every week, since it is it goes through its orbit every 29 and a half days, you're seeing it go from major phase to major phase every week.
Yeah.
So I think it would be really an interesting project. I might have to do this with my binoculars and camera, is go out every weekend and snapshot an image of the moon, and do it for an entire year and make a little video clip of it, watching it change its size. I think that'd be an interesting project. And it's great because astronomy that we have, it can be very expensive, especially when you get into larger aperture telescopes. But it also can be an inexpensive hobby to get into. I do recommend getting a pair of binoculars. I actually have my set right over there, and I have mine for about $70 US. They're great and they're portable, but you can always go out. You're able to see the details of the moon and some other objects out there. But very inexpensive way to get out, put it in your trunk, and say, hey, it's dark out. Let's go ahead and take a look and see what we can see. And you are able to see a lot of those beautiful features that are on the moon. You said that you started about 2 years ago to get into astronomy. What did you just go out and buy the biggest telescope you could, or what advised you into getting a telescope?
Actually, the first telescope, my first telescope, it's a 5-inch Maxito Cassegrain. It's also Celestron. I used it about 6 months. And there was a damping in the Celestron telescopes, so I just don't want to miss this and buy this one.
Uh-huh. And so this is your second telescope you have now, or how many telescopes do you have?
I have one.
You have one now?
I sold the other one.
Okay. And that's actually, it's quite common. That's a great way as well that you can purchase used telescopes from astronomers as they're upgrading, because sometimes you need a bigger mirror. And so that's a great thing too. So you are able to buy used telescopes relatively inexpensively than purchasing it new. And especially if you find a good astronomer that's taking care of their telescope, it's going to be nearly mint condition, but you also get that discount going along with it.
Mm-hmm.
So, as everyone knows, we're here with CosmoQuest, and what the main mission here that we're doing is bringing science to the public. So we all have the ability to do remarkable things, and we're all able to explore the universe in our own way. But with CosmoQuest, what we're able to do now is we're able to take these tools we have, like the Lunar Reconnaissance Orbiter and the NASA Dawn mission, and we're able to take that information and present it to the public. So we're taking research out of the ivory tower and presenting it to you. Everyone in the world is able to go through and map the moon, for instance. And so we're able to get more and more data coming through. And one of our main projects that has already brought back some preliminary data that's been presented to NASA Ames, that was back in July, is moon mappers. So if you go to CosmoQuest.org, I'm going to screen share this real quick to show what I'm talking about. So we have CosmoQuest.org and /mappers/moon. You're able to go through, and we have 3 different of ways of getting involved in citizen science projects. So our first one here is simply creators, and you're given the ability to take images taken from the Lunar Reconnaissance Orbiter, which are the highest resolution images taken since the Apollo mission. So since people have been on the surface of the moon, these are the next closest images, or resolution images that we're able to find. So you're able to go through and look for amazing features and map the surface. So we're able to see, yeah, it's not just a gray circle in the sky, but there is a dynamic geology that's going on. We're able to see light features happening. We're able to see that the sun is over here, so we're able to see shadow being on the right-hand side of this image inside the crater. So you're seeing the three-dimensionality happening from it. We also have many different features that you might be able to find. So we have our light and our dark albedo features, which is talking about when an impact crater has happened, what type of matter is being ejected once it's hit. We have boulder fields. So during the ejecta, we're able to actually go through and see that there have been boulders that have been thrown out from it. And so instead of being three-dimensional divots or these craters, we're seeing these three-dimensional figures on top of the surface. So you're all able to go through, and each image is gone through about 15 or 20 times by each unique person, and we're able to collect this data that has these beautiful images. You're all participating in this, and you're able to go through and see the statistics that everyone has done to participate in this. So we can see as far as everyone we've done in Simply Craters, man versus machine. We also have ice investigators, which is going over the Kuiper Belt objects. So with the New Horizons mission that's going out to Pluto, we're helping choose where it's going to be going after the survey of Pluto's happened. And then our newest one is Vesta. So we have our asteroid mappers. The Dawn mission just left Vesta, I believe, on the 5th of September, and is now headed to Ceres. And you're able to not only map the moon, but you're now able to map one of the largest rocks in the solar system, one of the largest asteroids, Vesta. And you can see here on this image that it's quite the dynamic rock that we have floating out here. And while you're able to do this, we have multiple Twitter accounts that allows you to interact with the science team, the education and public outreach team. With Asteroid, you can follow on Twitter at Asteroid Mappers, which is the personification of the Vesta asteroid. We also have at Moon Mappers or at CosmoQuest X. So we're always reaching out and opening that conversation to get everyone involved in science. While you are mapping, you're able to watch some of our previous broadcasts, and also there are forums where the actual scientists are there at the university. You are able to interact with them. So if you have a question coming up from some of the images or features that you're seeing, you're able to speak directly with the scientist that's working on this. So we want to take down these barriers and allow everyone to have an opportunity to be involved in science and actual scientific research and appreciating these wonderful bodies that we have inside of our own solar system. So I'm going to switch back over to Ahmed here, and his view of the moon is absolutely brilliant. So we were just seeing an image of the moon from the Lunar Reconnaissance Orbiter. So this was out in space. But Ahmed, he's on Earth. He's literally across the globe from me right now, looking up to the moon through the atmosphere and seeing this amazing detail coming through. And his histogram, which he just removed. But it's amazing that we're able to see the three-dimensionality. We're able to see these craters coming through, and we're able to see how just dynamic that these craters are hundreds of millions of years old, but they haven't changed much because there isn't that atmosphere. There's no erosion happening like we do here on Earth. It's stayed pretty much pristine, and we're able to go up and study these craters, which is why we're able to do moon mappers. It's not constantly changing. We're able to go through and map them and also see if there is a change. Something has just recently happened, and we can time that and try to find out what exactly is going on. Now, what's your field of view right now, Ahmed?
I haven't calculated.
Okay.
The camera is new.
The camera's new? Okay.
Yeah. But it's F10. There is no Barlow.
No Barlow? Okay.
Yeah. And I just capture a video, and maybe I can stack it.
Yes, that would be great.
If you
So
wish.
if you put it up on the YouTube, we can put it into the event page. But yeah, this is a great way for us to all appreciate looking at the moon. So if anyone is out there right now taking images of the moon, sharing in this worldwide event, please go ahead and put them in our Google Plus event page. And what's great is at the end of it, it's going to be compiling images from across the world of everyone sharing in this event, showing that this is truly a human way of looking at everything. That we all have this ability to look up, be curious, and yearn to explore.
Yeah.
Oh, and it looks like Christian's coming back here from Denmark. How are you guys doing?
Yes, Doug.
So the moon set for you, I take it, or are you there? Oh, looks like we might have lost audio. Okay. Let me just chat with them real quick to see if they can hear me. All right, and they can't hear me either. All right. Oh, and we're actually being joined now from David Riley. David is in the UK. I know that we were having threats of clouds in the UK. Oh, and David popped right out. So David is trying to join with us. But yes, the clouds were threatening in the United Kingdom. And here he is. He's joining back in with us now. Hi, David.
Hi, Scott.
How are you doing?
All right, thanks.
Very good. So,
yeah, the sky's still a bit light here, and there's cloud in front of the moon as well, so I haven't put a barlow on. I'm just showing the widest field I can get at the moment.
No, that's absolutely great, and that's actually a really good question that gets asked a lot, is why are we able to see the moon in the daytime? And that's because, well, it has to. The moon orbits us as we're orbiting the sun, and so there are going to be times when the sun and the moon are on the same side of the Earth. So there are times when it's the light is coming from the sun off the moon and coming down to Earth, because it is actually brighter than the sky itself. We're able to see it. So as you can see here on the left side of David's image, we're actually still seeing some blue sky while able to see the features that are on the moon. So it's absolutely brilliant. I love being able to see the moon in the daytime, knowing that it's not just a nighttime object, it's an all-the-time object. So what type of telescope are you using, David?
It's a 6-inch Newtonian.
All right, so 6-inch Newtonian.
Yeah, I may be able
camera?
to. Sorry?
And the camera?
It's a Philips webcam.
Okay, very good.
I might be able to show you a view of the telescope through. I've got another webcam here, but I haven't got it plugged in yet. But I might be able to show you a view of the telescope while it's still light.
Very good.
I'll give it a try.
So for those of you not familiar with our virtual star parties, David and Ahmed are both active participants in our virtual star parties every Sunday evening, U.S. at least. And there's an eclectic variety of different telescopes and cameras. Some are using a DSLR, like Canon and Nikon cameras that are streaming video, but some are just basic webcams that have either undergone surgery to be able to do prime focus, or some are just literally plugging the webcam up to the eyepiece to take a look through it. That's actually how I do my observation, which we'll be doing later on this evening in the United States and California. But we do have a wide variety of technology that's able to be used, so we're able to see different types of objects from these different types of telescopes from across the world. And Christian and Jens from Denmark did want to thank everyone for watching. They're having some tech problems, and the moon is going down, so they're going to be leaving and just watching from afar. But thank you guys for joining in. It's actually your first time in our Hangouts, and we definitely appreciate bringing in yet another country into the CosmoQuest group. So here's David. A little thumbnail of him with the moon.
So I'll try and turn this and get the... so there's a view of the telescope. If I just pick this up, actually, it might be better.
Right.
So there you can see the webcam going into the focus there.
Right.
And then if I come back a bit, there's the telescope mount. That's an EQ6 mount.
Okay, very nice. And that's actually something interesting, that a lot of times the mounts end up costing more than the optics you have on it.
And I think you might just be able to see the moon in that, just above that fence.
Yep, you're absolutely right. So I don't know if everyone can see here, but just above the fence in the center of his bottom frame, you're able to actually see the moon and see that the telescope is pointing at the moon.
See, the mouse is just about... I've lost it again now. I can't hold it steady enough to point. But, there you go.
No, that's brilliant. Thank you. Is there
any other view of the telescope you want me to get? Or?
No, that's absolutely great, David. So David was able to bring us 2 moons, the same moon, but from 2 different cameras. So fantastic.
Shall I move that out of the view now?
No, I've been asking people, do you remember the first time that you saw the moon through a telescope, David?
Yeah, I got my first telescope when I was about maybe 11 or 12. So that would have been the first time I saw it. It had a 60mm refractor.
Oh, very nice. I know for me, first time seeing it through a telescope, it kind of blew my mind. You're so used to seeing it as a 2-dimensional circle-ish object. Were you able to see a difference, or did it change the way that you felt about the moon when you saw it through the telescope?
I don't know whether it changed the way I felt about the moon. It was just brilliant to be able to see it close up like that.
Right. It's so easy just to take it for granted. It's just something that's always up in the sky. And I know for me, actually being able to see the features and the details, and that it wasn't 2-dimensional, it is 3-dimensional. It's a sphere, and it has all these violent impact craters on there, which is very fascinating to think about, and having it transform just by looking through some glass is just wonderful.
Yeah.
Now, Ahmed, is that a still you just took?
It's stock version. I just finished the stacking.
Okay, very good.
And also share it on the event page.
Oh, that would be great. So if you keep it up there real quick, on the right-hand side of the image, we see this crater, this beautifully circular crater, and then you also see this these boulders there right in the center of it. And what happened here is that there was such a violent impact that it shot down, and so the object that came out hit down was throwing up the ejecta. But it was heated up and liquefied and froze and dropped down right where it was thrown up. So we're able to see the sides there of the crater, but you're also able to see the impact point. So that's actually matter that was underneath the surface, shot up, frozen, and then dropped back down. We call those bullseyes on moon mappers. So you're able to actually go through on moon mappers and see different types of features and different types of craters, and that's one that we do call a bullseye. And over here on David's screen, we're able to see these darker areas mixed with the lighter features. So we're able to see that there are some newer and some older features on.
So that's the Sea of Serenity there, where my mouse is. Can you see that?
Yes, absolutely.
And then Tranquility next to it there.
So the Sea of Tranquility is where Tranquility Base, where Apollo 11 landed. And as most of us are aware that, I'm
somewhere
sorry.
around there.
Yeah, I believe
Somewhere around where the mouse is, isn't it?
Yes, I believe it's in the southern portion from the northern hemisphere of the Sea of Tranquility. But Neil Armstrong passed recently, and his memorial service actually I believe last week. But it's amazing to think about that. Yeah, we have this object that's almost 400,000 kilometers away, but we've sent a human being there, and we've sent multiple human beings there and back, and we are at a point where we're able to do so many phenomenal things. Yet right now it's just a matter of funding it. We have the technology, we have the means of going to different objects in space and learning more about it. Because learning more about space and learning more about the cosmos allows us to learn more about ourselves, because we're all a part of this, we're all connected within this cosmos. We all have the same chemistry and the same atoms that we're all sharing. And see here on the dark side, on the left portion here, it's called the Terminator, which reminds me of the dark side of the moon. Though it is a great Pink Floyd album, it's not an actual term. We always refer to the far side of the moon, because the moon being a sphere, it's always illuminated on one half. We just don't always see that half all the time. So when it looks to us as being a quarter moon right now, one half of the moon that we see is illuminated, well, the other half that we don't get to see is also illuminated, which is why we do call it a quarter moon. And so the other side of that is what we call the far side of the moon, because it's just that part of the moon that we don't get to see. Very nice. Now, I'm loving that it's in daylight, so we're able to add. It adds a little bit of color looking through the atmosphere, and then we come back over to Augment, where it's a few hours later in the day, and it's completely different. You're just seeing the stark contrast of the sunlight hitting the Earth and the shadows being cast from the ridges in the crater, right there on the Terminator as well.
Yeah, that's a fantastic view from Armet there.
Now we are. I will be asking any questions coming up. So for any of you guys watching here, we are on Twitter using the hashtag Moon Knight. Also, if you have any questions on Google+, please feel free to leave any comments on any of the shared of this broadcast. So we'll be able to check the comments going on there. But I know there's a few people across the world, especially now that it's becoming in the day here in the States, there are actually quite a few local events. So if anyone's having any events going on now too, watching this later, please feel free to add your images to our Google Plus Hangout event page, and we'll be able to show everything that's been able to happen here. Oh, very good. So a question that was asked earlier this morning for me, but it was actually in Australia, is why aren't we able to see any of these stars when we're looking at the moon? And it's just a matter of contrast. So the moon is so bright, it's actually the second brightest object in our sky. And just like if you're driving down the road and you see someone with headlights coming in, you're not able to see things surrounding it because you are being blinded. That's very similar to what the moon is doing. Since it's so bright in the sky, we're not able to see the faint, dim stars that are on the edge of it. But once it moves out of your field of view and the brightness is gone, then those stars are able to resolve. So there's been some conspiracy theories about the moon landings that have come up. Well, we're not able to see the stars in the sky. Well, no, because it is so bright that those other stars are not bright enough for the camera to be able to resolve those stars. Catching up with a few comments here. I know one of my pals, Ashlyn, he's in Australia. Trying to pull up that question he asked me just a while ago. Let's see here. And I apologize. I'm much better with a co-host, so doing this on my own is a little daunting, but we'll get this going. So, with the impact craters that we're seeing, that there's so many that are out there, so it's definitely just, pockmarks all over the place, just many impact craters going on. And the newest ones that we really know of that we're able to date, as far as the larger impact craters, are 300 million years old. So that's young, because when we're talking about the time of the universe, around 14 billion years old. And with the Earth and the Moon at over 4.5 billion years old, 300 million years old is not all that old. So there used to be active volcanoes on the Moon, and so we actually have lava tubes that are actually collapsing and being able to see inside them. And these craters, we're able to judge how old they are based on the color of the matter around it, because it's being bombarded constantly with solar radiation, and that actually affects and darkens the matter that's on there. Plus, when you're able to look out in the Moon, where they have the Sea of Tranquility or the Sea of Serenity, we have these large seas that were actually lava flows, so very smooth, which are very young features that don't have all the craters that have been over the billions of years. They don't have that large amount of craters there. So we have these seas that are just old lava flows that have been solidified and frozen now. But it gives you an idea of thinking that the Moon was not always this dead ball up in the sky that's just kind of gray and no personality. No, at one point there was active volcanoes happening, just like we have on Earth, and lava flows. I know, like in Hawaii, that we're able to see these lava flows happening. We actually had these on the Moon. So thinking of the Moon as something that was active geologically, so it's changing and moving all over the place. That's something that we don't necessarily get to think about all the time. And it's a great way of thinking about on a timeline of the Earth, that the Moon itself has changed dramatically from when we first started to know our companion up here in our orbit. Oh, it's great here, Ahmed. There we have our large crater up in the top of your image, but we see many tiny craters coming around. So there's another bullseye crater, but we get to see all sorts of different types with the albedo features going on as well. So the lighter regolith and the darker areas as well. So you're able to get a sense of the time that's been going on here.
Scott, I want to ask a question to you.
Yes.
When I look at the Moon, sometimes the crater seems like hill instead of hollow. Do you ever feel like that?
I'm sorry, I didn't understand.
When I look at the craters, sometimes they seems like hill, mountains.
They seem like they're sticking up instead of down.
Okay, yeah. Well, because there are actually boulder fields on the Moon, and a lot of it comes with the trajectory of the object coming in that creates a crater, and large chunks of the lunar surface gets thrown out. So you do actually have these very large boulders that are three-dimensional in the other dimension. So we see craters all the time sunk in, but we do see hills and we do see rocks being thrown out, very large rocks, larger than buses and things like that. They're actually on the surface. So there is a terrain. It's not just a smooth body with holes in it. There is a dynamic terrain that's going on there. We do have a question here from Guido Bibra, and it's regarding telescopes. Are refractors or reflectors better for moon observation? So that he's got a little 67 or 700 Newton or Newtonian, and it's great for the moon. But he's thinking about switching to a Celestron Power Seeker 80. What do you guys think? I observe with some different objects that aren't my own, but I know that you guys do have your own telescopes here. What would you guys advise for Guido there?
Oh, I am not expert. I just use 2 telescopes.
Right. And you've always used a reflector?
Yes. Yes. The first one is Max-Stowe Cassegrain, and this one is Schmidt-Cassegrain. Oh, I never used Newtonian.
And how about you, David?
I think any telescope will show a really good view of the moon, really. Even quite a small one, you can get a really impressive view of the moon.
Oh, absolutely.
I'm not really sure whether I'd say a refractor is better than a reflector or not for the moon.
You know, I mean, I have my binoculars here. These are a set of Celestron. They're 15 by 70 millimeter, and they are refractors because you are dealing with lenses instead of mirrors. And I got these I got them off Amazon. I got them for around 60 to 70 US dollars. And they're fantastic for looking at the moon. They're absolutely wonderful. I've actually been able to do some lunar astrophotography with it with my webcam, doing some still shots. And if you get solar filters, you're actually able to use those to look directly at the sun and getting to see sunspots. But that is another great way of doing some lunar observation, is getting a good pair of binoculars. And yeah, mine's only 70 millimeter for the aperture for these refracting binoculars. So most even telescopes you can go in and purchase even at a big box store, you'll be able to see the moon quite well because it is so close. Being able to look at different planetary objects, that's something that I would recommend shopping around for and finding out what specifications you are wanting to do, whether you're taking photos or just doing some wonderful observation. But as far as just looking up at the moon, you have many options, and honestly, most everything, besides the Hubble Space Telescope, works really well as far as looking at the moon. So thank you for that question there, Guido. And it's great. I'm seeing over here on Twitter there are many people that are doing events all across the world. I'm seeing here that, let's see, it's Interplanet Sarah is talking about in Houston that she will be talking about the moon at the Lunar Planetary Institute tonight from 7:30 to 9:30. So again, if you guys are going through on Twitter and doing the hashtag Moon Night, you're able to find local events all around you, and you can also go to observethemoonnight.org, and we have an interactive map there where you're able to find local events that are happening wherever you are. Most of them are free. I know the one that I'm posting later this evening is free, and it's a great opportunity to get out, look through the telescope, look at the moon with your eyes, and see these features in the way that you've never seen them before. A lot of them will have interactive activities like Nicole did with as far as the flower and throwing marbles down and watching how craters are formed, because the surface of the moon is very powder-like. And it's just a great way of getting to know our closest neighbor up in the sky, the moon. So by all means, please, I recommend that go out. It's Saturday. Find something awesome to do that the rest of the world is literally doing right now. We're all getting together to get to know the moon better. And David, I'm still loving your view of the moon there with the dusk happening right now. So you are still seeing able to see some of the sunlight coming through with the blue sky. Love that.
Yeah, the cloud's getting thicker now. It looks reasonable on my capture window from the webcam, but on on the actual Hangout view, it looks a lot more blurred.
Mm. Well, it's still coming through great on my end. I know that while we're going through to the broadcast on YouTube, that it will die down a bit in quality, but it's still looking great. You're able to see on the Terminator the different shadows of the craters and the different features going on. But no, it looks really good.
Okay.
And switching back over to Ahmed here, we're able to see that contrast between the type of material there on the moon. So we have the darker regolith on the left, and we're able to see the lighter features on the right. So you're able to really see how the moon isn't necessarily just one bland, just object in the sky. There's a lot of features, and there's a different type of geology going on. So you do have a harder, rocky area, but then you also have a softer powder that's on top of it. So that's why we're able to see these different types of craters and different types of features that are on the moon, just because there are differences going on there. Just like we have different types of minerals on Earth, we do have different types of geology on the moon. Let's see here. We have our buddy Mike Rector. He's one of our astronomers, and he's saying great views of the moon. He'd love to share, but the thick clouds and rain are holding him back. So someone out there, please do the no clouds dance for Mike, and maybe we can clear up and add some more people as the day goes along. And Carolyn, let's see, Aquorna, I hope I pronounced your name right. I'm sorry if I didn't. Sometimes when I'm looking at photos of the moon, I get the optical illusion of craters looking like domes. I've heard it might be because it's not easy to tell where the light is coming from. Sometimes turning the image upside down helps. And absolutely, when we're looking up, it's so far away that it's hard for us to resolve whether it's concave or convex. And on moon mappers on CosmoQuest, we actually give you a hint by putting where the sun's coming from on the image itself. So I'll actually pull that up right now and give you an idea on a great way of knowing whether it is a hill or whether it is an actual crater. So maybe go and screen share this real quick. Here we go. So as you see here on moon mappers, we have the sun, this little icon right here, and this is showing where the direction of the sun is. So the sunlight's coming across this way, and so you have this crater here where it's dark, so this is where it's gone into the surface, and here's the other edge of it where it's being lit up as it's coming out. And we're able to see all the different features coming along. There's another dark area, and it's light on the other side of that crater. But it also allows you to see the difference between a crater, and sometimes there's a hilly area, just based on what side that the sun is on. So if you're looking up at the moon, and you're able to see where the terminator is, so where that line separates the light from the dark, wherever the terminator is, the opposite side of that is where the sun's coming from. So you're able to tell, based on where the shadow is cast, if it's going to be actually a hill or a boulder, or if it's actually going to be a crater there. So that's a fantastic question. And it's something that we actually implement into moon mappers on CosmoQuest to allow you to identify the difference between a crater and a hill, because when we go through and classify scientifically to make sure that everything's congruent with the data, we don't want to have a hill being mapped as a crater or vice versa. It allows us to get a better understanding of what's going on up there. So thank you, Carolyn. It was a great way of approaching that. Yeah, it's good to look at upside down, and it's good to take a look at where the moon is and where the sun is shining on it, so you get an idea of that, of if it's going to be a crater or a hill. And Mike just let us know that he's done the no clouds and rain dance before it started, but he thinks he's angered the gods. So yes, though astronomers are all about empiricism and the scientific method, we do silly, superstitious things like do the no clouds dance. I don't know if we actually do it. We just say we do it, but there are a lot of us that we do curse the skies. One of the major superstitions that if someone bought a new telescope or some sort of new technology for doing some observation, at least for the next week, won't be having some horrible skies and you won't be able to actually use it. Or whenever we have virtual star parties, we often have tech problems as well. So just checking more comments here, and again, they've been great so far. Thanks again to Carolyn and Guido there, and also from the people in our earlier sessions. We do appreciate your comments and your questions going on, whether it be with the telescopes, features on the moon, what we're able to do or not do. One of the main questions going on in our previous conversation was about what missions will we be able to do on the moon, as far as being able to put a moon base up, which would be awesome. I would sign up immediately to go do that. And one of the places that we were looking at, there is in a polar region of the moon that is actually sunk down, so you have this natural shielding from radiation. And yeah, it's cool. It's really cold there, which means that you only have to worry about heating up, not cooling off. Because when you're having no atmosphere, you do have a very large temperature change between daylight and nighttime. So if you're in an area that's constantly shaded, you only have to worry about heating up, and you already have this constant shielding just from being inside, being embedded inside the moon itself. There are plans for missions, but I have my own plans for things to do. Right now there's a lot of funding issues that are going on, not only in the U.S. but also across the world, and we do need people like you to get out there and advocate, saying no, that planetary exploration is important. We need to know more about our neighbor, the moon. We need to be able to go out and put more robots on there and put people on there. But what we're thinking about is what might actually happen is that it will turn into a tourist destination first, because we largely live in a capitalistic society where you need to make money, and we're not having funding right now. So we have these wonderful programs like SpaceX and Virgin Galactic, which are bringing private companies to space. So it's very possible that it might be a company that brings us to space first and bring us to the moon again. So it might be a tea house on the moon, and we would love to have traveling lectures on the moon and be able to entertain the rich while they're traveling to the moon. And hopefully one day we'll be able to actually have more people and become more affordable. But there are active robotic missions going on as well. We do have the Lunar Reconnaissance Orbiter that is currently up there on the moon. Plus there's the Google Lunar X Prize, and with NASA there's the Lunabotics program. So it's imploring people to think about ways of getting to the moon and do science and being able to excavate rocks. So you have a certain amount of mass of rocks that you're supposed to collect and be able to move around within a certain time period. So there are these challenges to get people excited and thinking and using their imagination of what we can do on the moon, because it is something that we don't know everything about. We fairly recently found out that there is water ice on the moon, something that we never really thought about having before. So we're following that water and we're following that ice. So we're finding more things out about the moon every day, and we've been able to look up at it for thousands and thousands of years as humans, and now we're actually able to get scientific knowledge and find out what the basic building blocks are happening up there. And yes, Mike just let us know that he may have done a little dance. Sorry, I told, even though he told me not to. So thank you, Mike, for doing your no clouds dance and me putting on blast for the entire world. Now, David, what time is it out there in the UK? Is it 7:30, I believe?
That's right, yeah. It's 7:30.
7:30 p.m. So you're at Greenwich Mean Time, or UTC. Out here in California, it's 11:30, and for my friends in Australia, it is 4:34 Sunday morning. So good morning if you're up watching this. I know that Ashlyn and I know Teal might be as well. So I'm glad that everyone's able to get involved and being able to share in this event with everyone.
I just put the other webcam on the back of the telescope so you can see the view
beautiful.
on it there.
Love that. So as we're able to see here, we do have the backdrop. We are seeing the moon through the telescope, but we're actually able to see the moon and the telescope through his other webcam. Oh, I love that. We all have so many different ways of looking at the moon. With technology these days, we're all able to have so many different cameras linked up to it. Well, we are reaching a good point here. I'm not getting as many questions, and I do need to sleep at some point because I have only been getting a couple hours sleep before my next event. So I think this is a good way to cut off before we do have our next big broadcast from the United States. We'll be starting up around 5 p.m. Pacific time, which is going to be, I pull up my converter for at 7 hours. So it will be 2 a.m., 2:30 UTC is when we'll be starting our final broadcast for International Observe the Moon Night. So we'll be joined by many frequent faces that you've seen in the virtual star parties. Plus, we will have Georgia from Southern Illinois University at Bridgeville, another wonderful component of CosmoQuest. She'll be on site with an event out there. I will be on site at Citrus College in Glendora, California. And we might have some special guests surprising us as well, as Fraser is hosting the event while we're out on site. So I want to take time to thank David and Ahmed and Christian and Jens. But thank you so much for sharing your view from across the world and from different places. That's absolutely wonderful. I love that we're able to do this and get everyone involved to look up at the moon. Is there anything that you guys want to add before we sign off? No?
Thanks you for watching.
I'm off to a real star party later tonight, so I'm hoping to get a picture of the Lunar X from there if the cloud goes away. So I'll post that if I can manage it.
Oh, very good. Yeah.
I won't be able to broadcast from there because I can't get a good enough connection.
Okay. Well, if you could just take those photos and put it up into our event page, that would be wonderful. So we can see later on what you were looking at. And for anyone that is going out to any live events in person, please take photos. We want to share in the fact that we not only are just a bunch of nerds looking through our telescopes by ourselves, but we do go out and we love sharing this experience with everyone and showing about, teaching this to young kids or kids of every age. We're able to enjoy the moon. We're able to enjoy the night sky. And so, yeah, show off your outreach. I know Teal was showing many people dressed up as stormtroopers because the 501st Legion was down there in Australia with his event, which is awesome. Great charitable group for children and Star Wars. So Star Wars is always fun, right? So again, just for signing off here, I'm Scott Lewis. I am Bald Astronomer on Twitter. We have Ahmet Kil, and he is from Turkey. We have David Riley from the UK, who will also be doing an in-person star party this evening. We are CosmoQuest here, so you can find out more information about doing citizen science at www.cosmoquest.org. You can follow us on Twitter at CosmoQuestX, as long as our specific programs at Moon Mappers, at Ice Investigators, and at Asteroid Mappers. So you can always work with us. We are always looking for different ways to interact with the public on Twitter and social media. You can join the forums there as well. We've merged 2 months ago, I believe, with the Universe Today forums and Phil Plate's Bad Astronomy forum with the CosmoQuest forum. So it's a great way, many resources available at your disposal. Again, thank you everyone for joining us. We will see you in about 6 hours for our final big event here in the States. Everyone have a great day.
Bye.
Thanks.